Hello. In the previous video, we learned how to find the trigonometric form of the complex numbers. In this video, we will do some examples in which we will convert Cartesian coordinates of the complex number to the polar coordinates or the trigonometric form. Polar coordinates or the trigonometric form is the same thing. So, we are given some examples. So here is an example. In this example, we have to find the polar or the trigonometric form of the following. And here we have three different complex numbers, and we will find their trigonometric or the polar form. So let's solve them one by one. So first of all, we will solve A. In order to find the trigonometric form of Z, we will need to find first the modulus of Z and the argument of Z. Argument of Z is usually denoted by theta. So these two things are needed to find the trigonometric form. Remember, in the previous video, we proved that, we have discussed that if Z is a complex number, which is a plus b iota, then the trigonometric form of Z is equal to modulus of Z times cosine of theta plus iota sine of theta. So this is called the trigonometric form of Z. Okay, so Z is equal to, the trigonometric form of Z is the same thing as Z. This is equal to the modulus of Z times cosine of the argument plus iota sine of the argument. We have shown in the previous video that Z is equal to this thing. So in order to find this thing, we need modulus and the argument. So that's why we need to find the modulus and the argument theta first. So the argument is determined by the modulus is determined by a square plus b square. If you look at Z, here the real part is a and the imaginary part is b. That means when I am saying a square means I am taking the square of 2. So I will write square of 2 plus, what is b? B is again 2, so I will write the square of 2 again, which is square root of 4 plus 4. That means square root of 8. Square root of 8 can be written as 2 square root 2. So this is the modulus. The modulus of Z is 2 square root 2. So I will save this value for later because I have to use this value in this formula. But first I have to find the theta. What is theta? Since argument theta equals tangent inverse of b over a, here my b value is 2 and a value is also 2 because my Z is equal to a plus b iota. If I solve it, I will get tangent inverse of 1. Since if you calculate the tangent inverse of 1 from the calculator, you will get 45 degrees. Just like the previous video, I told you your theta can be either this angle or you can add 180 degrees in it because the period of sine theta is 180 degrees. But if you write theta equals 45 plus 180, it's equal to 225. Okay, but if you make the diagram for this complex number and represent it onto the complex plane, since the complex number is 2, 2, so I have 2, this is 2 comma 2 because 2 plus 2 iota. This 2 means we have to move x-axis along the positive sides by 2 units. So this is the x-axis and this is the positive sides. We have to move by 2 units, 1 and 2. And the second 2 means we have to move along y-axis along the positive side because the number is positive by 2 units. This is 1 and this is 2. So we will join these 2 points. So this is my vector, okay? So my vector is this one. Okay, so I can write here 2 comma 2. Okay, so in the first quadrant, my angle is this one. From 0, okay, from 0 to here, I have 90 degrees, but I have 45 degrees and 225 degrees. So from 0 to, okay, this is 45 degrees. And if I go here, this is 225. But my point is in the first quadrant. So that is not here. So that means the 45 degrees is correct because this angle correctly determines my point. Because I have 2 different angles. The one is 45 and the other one is 225. Okay, if you just rotate this x-axis by 45, you will go to this point. Otherwise, if you rotate it by 225, you will go from here and here. But on this line, you cannot find this point because this point is on this line, which comes after rotation of only 45 degrees angle. So that means this is correct angle. This angle does not determine our point because our point was in the first quadrant. Hence, argument of z, which is theta, is equal to 45. Okay, so from the previous video I told you my polar form or the trigonometric form of the complex numbers is this. So I will use this formula because I have found the modulus as well as I have found the argument theta. So I will plug these values here in this formula. Since modulus of z, which we have found, is 2 square root 2, so I will plug this value here, 2 square root 2 times cosine of theta, and theta is 45 here. I will plug here 45 plus iota sine theta. Again, theta is 45, so I will plug here. This is the trigonometric form of my complex number. If I solve part B of this question, so in part B, I have z is equal to negative 4 iota. If I write it in a plus b iota form, that means I can write 0 minus 4 iota. So here, a is equal to 0 and b is equal to negative 4. Okay, so that means my a and b are found. So first, our first task is to find a and b. Okay, now we will find the modulus. What is the modulus of the complex number? It's just the square of a plus square of b whole thing square root. If I plug the values, square of a means 0, square of 0, plus square of b means square of negative 4, square of 0 means 0, square of negative number is always positive, since the square of 4 is 16, so I will write 16 here. So 0 plus 16 is 16. Square root of 16 is 4. So the modulus of z is 4. Now I will find the angle theta. Since theta is equal to tangent inverse of b over a. Okay, if I plug the values, tangent inverse of what's b? b is negative 4. So negative 4 over a is 0. Okay, since something over 0 is infinity, but I have negative also, so I will write negative infinity. So tangent inverse of negative infinity, if I solve it, I'll get negative pi by 4, pi by 2. Negative 90 degrees, pi by 2 is 90 degrees, so I will write in degrees. Okay, so since the period of tangent theta is 180 degrees, so I will check whether if I add 180 degrees, this is correct answer, or if I add 180 degrees here, if we add 180 degrees, then we get negative 90 degrees plus 180 degrees, we will get 90 degrees. So we will check by using the diagram, by representing the complex number on the complex plane, that whether this angle is correct or this angle is correct. So here is the complex plane. My complex number was negative 4 iota, right? 0, negative 4 iota. That means along x-axis I have to cover 0 distance. That means I have to stay here. Along x-axis I have to neither go right or neither go left, because x is 0. Along y-axis I have negative 4. Negative 4 means along y-axis I have to go down by 4 points. 1, 2, 3, 4. So I will stay here. Neither I will go here, nor I will go here, because along x-axis I have 0. So my vector is from the origin to this point. Okay. Now if we check, if we measure our angle from here to here, we have 90 degrees because it's the positive direction. But if we measure from here to here, it's negative 90 degrees. Okay, where is my point? Does my point lying here on this line or on this line? Obviously my point is on this line because I have drawn arrow here. So that means this angle is correct. Okay, so this angle is correct. This is not working. Okay, because this angle, if I go from x-axis and cover this angle, I cannot get this point because I'll be going here and this line is going up. So I cannot reach this point. I can only reach this point if I make negative angle from here to here, which is negative 90 degrees. Okay, so my argument is negative 90 degrees. Once we have found the argument and the modulus of the complex number, then the trigonometric form is, since the trigonometric form is cosine of theta plus iota sine of theta times the modulus, I have the modulus equals to 4 because I have already computed it in this question, and cosine of negative 90 degrees plus iota sine of negative 90 degrees. Okay, now we will do the C part of this question. In this part, my Z is equal to negative 2.5. I can write negative 2.5 in this way. Negative 2.5 plus 0 times iota, because here there is no iota. So I can write 2.5 plus 0 iota. Okay. Here if I compare, my A value is negative 2.5 and my B value is 0. Okay, so in order to find the modulus of the complex number, which is A square plus B square square root, if I plug these values, this value and this value here, I will get negative 2.5 square plus 0 square, because 0 b is equal to 0. If I plug these values and solve by using calculator, I will get 2.5. If I solve this whole thing by calculator, I'll get 2.5. Now we have to find the argument theta, which is equal to tangent inverse of b by a. Okay, so but tangent inverse of what is my b? My b is 0. A is whatever, I don't know. AA was 2.5, negative 2.5. So 0 by something is 0. So tangent inverse of 0 degree is 0 degrees. Okay, now since the period of tangent is 180 degrees, so if I add 180 degrees in this angle, then we will get 0 degree plus 180 degrees. We will have 180 degrees. Okay, now we will check whether this angle is correct or this angle is correct. Okay, so what we will do, we will represent our complex number on the complex plane in order to check which angle completely determines our complex number. Since our complex number is negative 2.5, in other words, if I write it in commas, I have negative 2.5, comma 0. That means along x-axis, I have to go 2.5 units to the negative side, and along y-axis, I have to go nowhere. Okay, so along x-axis, I have to go, okay, so this is the point, negative 2.5 and 0. That means along x-axis, I have to go 2.5 units on the negative side. Since this is the negative sides on the x-axis, so I have to go 2.5 units, 1 unit, 2 unit, and 2.5 units. So this is the point along the negative side of the x-axis, and along y-axis, neither I will go up nor I will go down, because along y-axis I have to go to 0 distance. I have to cover 0 distance. Okay, so I have to draw a vector starting from the origin to the final point. Okay, so this is my original vector. Okay, so now we measure our angle from the positive x-axis. If I go nowhere, if I go up, I will go plus positive angle. If I go down, that means I am covering negative angle. If I stay here, if I go nowhere, that means I am covering 0 degrees. But if I am staying here, I cannot find my point because I am on the positive side. So, but if I go from here to here, I cover 180 degrees, then I can reach to this point. Okay, because I can touch this vector if I cover this 180 degrees. So that means our correct angle is 180 degrees. Okay, so that means this is wrong. This completely determines our complex numbers. Okay, so the trigonometric form of the complex number is z is equal to modulus of z times cosine of theta plus iota sine of theta. If I plug their values, since this is equal to 2.5 because I have already determined it, and cosine of 180 degrees plus iota sine of 180 degrees, because my angle is this one. This is my argument. So argument, you have to find argument carefully. If you find the argument carefully, then you can easily convert your Cartesian form of the complex number into the polar form of the complex numbers.